Good. So we're going to do 1 is really 1 times 10 to the 0. 10 to the 0 is just 1. So we're going to do 1 divided by 6.65. And then separately we're going to do 10 to the 0 divided by 10 to the negative 14. And remember, when we divide, we take this part and we subtract that part. When we subtract a negative, it becomes positive. Like the opposite of a negative is a positive. So the green part,
So you have 0 and you minus 14, isn't it minus 14?
nope. You minus negative 14. We're not taking 0 and subtracting 14. This is not 14.
Well, it's negative 14.
It's negative 14, so we're subtracting negative 14.
And you have $0
And you subtract negative 14. So I owe you $14. If I subtract that, if I undo that, what's the opposite of owing you $14? What's the opposite of me owing you $14?
I owe you 14.
Yeah, I have $14. So we're taking the opposite of it. So let's do the first part. What's 1 divided by 6.65? Did anybody do that? Anybody take 1 and divide by 6.65?
0.15.
0.15. Give me one more decimal place. That's it?
Oh, I just rounded to 3 sig figs because that's all we have.
That's 2 sig figs. I need one more.
Oh, 0, right.
0? Okay, great. Thank you.
0, yeah.
Okay. And then 10 to the, this is going to be 0 minus negative 14. So again, if I subtract a negative, I take the opposite of a negative, it makes it positive. It says the opposite of negative 14. The opposite of negative 14 is positive 14. So it's going to become 0.150 times 10 to the positive 14. Which makes sense, because if a bacteria weighs this much, really, really small amount, I'm going to need a lot of them to equal 1 gram. You guys with me? It should take a lot of these bacteria to equal 1 gram. Because they weigh 10 to the negative 14th. They're really, really tiny. They weigh 0.00000000665, right? I'm going to need tons of them to equal 1 gram. So I'm going to need 10 to the 14th of them, roughly. A little bit less than that. So if I were to write this in standard notation, I need to move this decimal place over 14 times. So I need to move it over 14 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's where my new decimal place goes. Add in zeros to make up the difference. That's a lot of zeros. So it's going to, in standard notation, it's 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 5, 0. That's standard notation. What's that in, right? I just moved this decimal place over 14 times. Just move it over 14 times. Do it yourself on your paper. Don't look at mine.
Oh, I did. I'm just counting yours.
Yeah.
I already did it. Yeah.
Yeah. And then everybody put this, everyone has this on their paper in standard notation. Write it in scientific notation. So now that's standard notation. Circle it. And then change that, and then rewrite it in scientific notation. So scientific notation, it should be 1.50 times something.
I think, wait, did you do it the opposite direction? Because it should be like 150.
Oh, I'm sorry. Oh my God. Nobody catch that earlier. It should be a really big number. I made it a really small number. So yeah. Yeah. So remember I told you guys I was going to make a mistake. And I told you the sooner you catch it, the more pain you save all of us. Now everyone's got to erase their stuff. Okay, I need to make this larger, thank you. So I'm glad you said it then. 1, 2, 3, 14 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's where our new decimal place is going to go. So it's 1, 5, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And put commas after every third one. Wow, that's really big. So this is our regular notation. That's a lot. That's a lot.
I think you're off by one.
Am I off by one,
It
really?
should be 150, whatever, quadrillion,
1, 2,
trillion.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Maybe on the bottom, you're off by one. When you copied it down.
I don't think so. What are you guys getting? You got 150,000 also? So are people getting 150 instead of 15 in front? Who got 15 in front? Who got 150 in front? Gosh, okay. Let's do this again.
Oh.
14. 1, 2, 3,
I just put column in the wrong place.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
I just put the column in the wrong place.
You started with the 1.50? Yeah.
I got
That-
15,000.
I did it 3 times and I'm still getting this.
Yeah, I got that.
Can you double check one more time? Just move it over. That's why they usually work in scientific notation, because it's easier, right, when you have all these zeros. I move it over 14 times. So if I start off here, I should move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that should be right. Okay, so now, everybody, write this in scientific notation. Thank you for checking, because it's definitely, like I said, it's better to be sure than to not be sure. So basically I need to move it back over, but I only need to move it back over 13 times. So I'll end up with 1.50 times 10 to the 13. So I want to have B right here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
So how do you know it's 1.50 instead of 1.5 times 10 to the?
Because you put a 0 here. Because we know we've kept it in 3 sig figs. Because you know you had it in 3 sig figs. You don't here. Here you don't know from here to here. But you know from here. Does that make sense?
Yeah, I'm just getting all these numbers.
Yeah.
Because I keep thinking we did it already in scientific notation, and then you're saying change it.
No,
to
it's not quite.
scientific-
Because this is not quite scientific notation. Because the decimal place is in the wrong spot.
Oh,
If you want in scientific notation, you gotta shift it over 1.
right,
If I shift it over 1, I gotta take a 10 from here.
right.
Yeah.
So technically you can get the scientific notation to the equation just by moving the decimal over 1 and taking off.
Yes.
Yeah,
So you could get from here to here by saying, I need a 10, so I'm going to take a 10 from here and make that 10 to the 13th. Totally. Absolutely. All right, let's take a break. Let's take a 10-minute break. We'll come back or we'll take a 13-minute break. We'll come back at 12:20. How's it sound? Relax a little bit, walk around a bit, get some fresh air.